Hello my dear champions, welcome back to our channel. I hope all of you are doing really great. So this is another session in your Masterstroke series. We're going to discuss two chapters today, straight lines and conic section. These are simple ones, straightforward formula based chapters and not a very difficult problem. We have not seen them in the PUCs of these two chapters if you go in the last 10 years. Okay, so let's understand this very clearly, and I'm very sure that you can score out of out marks. Means one question comes from each of the given two topics. So two questions you can solve clearly from here. Again, this is a theory lecture. Let's try to learn the concepts over here. For practice, you are following our 15-day challenge, so you can solve questions over there. And of course, for more question solving, you can either choose our KCET crash course or our ABHYAS test series for the mock test. The crash course is going at the price of 1,999 and the test series is going at the price of 999. You can choose whatever you want to. It's your preference. Let's start the session right now with this on the chapter straight line and conic section. Okay. So what do we have? First thing is, the first thing starts with, of course, the distance between 2 points. So when we talk about straight line, we'll start from the concept of your 2D space only. So if I have 2 points like this, A, x comma y, and B, we have, let's say this is x1, y1, and this is what? Okay, let me write it again. So if I have, sir, point A, x1, y1, and point B, x2, y2, and we're talking about only 2D space, means in a plane, then what happens is the distance between the point A and B is given by this formula, that is AB equals to root of x1 minus x2 or x2 minus x1 does not makes a difference, so we're gonna go like this, x1 minus x2 the whole square plus y1 minus y2 the whole square. This represents the distance between any two given points. Now when it comes to three-dimensional geometry, when we talk about 3D geometry, then you'll have a third coordinate which will be z1 and z2 that you have to add over here as z1 minus z2 the whole square. I hope this is clear. Okay. That's what it is there in this particular concept. How do you find it? Very, very simple. Just remember the formula. Okay, x1, difference of x coordinate the square plus difference of y coordinate the square taken as sum is the distance between 2 points result. Okay, now next, as I mentioned, the chapter is very simple, straightforward, does not try to trick you. Let's look at the important concepts over here, which is going to be your distance formula, section formula. Then we move on to your different types of forms of straight line, and there their mirror image is there, the reflection is there, all those questions are also there. Let's start with this one. Now when we talk about section formula, we have two types of sections. So section, one of them, a very commonly used one that you might have seen also earlier, if I have point AB over here and point P, means first of all the point A coordinate is x1, y1, point B coordinate is x2, y2, and point P coordinate is x comma y. P lies on AB. Then the ratio, let's say AP to PB, the ratio AP to PB is given by m is to n. This is the case of first one, internal section. This is the case of internal section. When the point lies between the 2 points, then the coordinate of the point x comma y is given by x is mx2 plus nx1 upon m plus n, and y is my2 plus ny1 upon m plus n. Okay. When you talk about this is your first case. When you talk about the external case, what happens over here? In this case, the point lies outside the line AB. So this is my line AB, right? Then the point P will lie outside the line AB. This is called as creating external section. How does it work? So in this case, the ratio AP will be, section AP will be like this, and PB will be over here like this. So the point P is outside the line AB. Getting it? Again, same result, AP to PB is m by n. And how do you find the section? Or basically the coordinate of the point P, which is x comma y, right? X comma y, you find it like mx2 minus nx1 upon m minus n, and for y coordinate m by 2 minus n by 1 upon m minus n. Okay, what about midpoint formula? This is simple result. So basically sir, in this result, you take m by n as 1 by 1, because when you talk about midpoint theorem, what happens is, or midpoint formula, what happens is, the point becomes, of course, the P becomes the midpoint of AB. So the sections are equal, m and n are equal sections, 2 equal halves. So m by n becomes 1 and 1. If you do that, you get what? x2 plus x1 by 2 y2 plus y1 by 2. Okay, simple concept. Moving on. Okay, next is area of a triangle. Again, if you have three vertices known, like this, A is x1 y1, B is x2 y2, and C is x3 y3, then the area of triangle ABC in terms of the coordinates of vertices only is given by half of x1 times of y2 minus y3. So basically, how do we remember, sir? First of all, keep here half. Why modulus? Because it's an area. Will area be ever negative? No. That's why we keep it outside as modulus. Whatever is the calculation inside, it should always result into a positive quantity. So modulus outside. Right here x, right here y minus y. Same thing. Plus same way x, y minus y. Same thing. X times of y minus y. Close the modulus. Now here, start from this. 1, 2, 3, 2, 3, 1, 3, 1 and 2. So have this cyclic sequence of writing the numbers, you get the result. x1 y2 minus y3, x2 y3 minus y1 and x3 y1 minus y2. Cyclic order of this 1, 2, 3, 2, 3, 1 and 3, 1, 2. That's the way to remember the formula for area of triangle. Okay. So as I mentioned, the concepts are very straightforward and simple, just that we have to remember these. Alright. Next. Let the triangle ABC, okay, one more thing I missed over here is that if the triangle area is 0, what happens in that case? If the area is 0, so basically this triangle that you look at this over here, this point, so this was, let's say, the line BC and A vertex was over here. It keeps moving to the point, towards the line BC. It means area is reducing, and there comes an instant when the point A lies exactly on the line BC. Then the point ABC becomes collinear. The points ABC becomes collinear. So when the ABC becomes collinear, what happens to the area of triangle? It's not a 2D shape anymore. It is a straight line. For any straight line of one dimensional of shape, there is no what? Area. Okay, that's why area becomes 0. Okay, next. In the knowledge of, let triangle ABC with the vertices x1 y1, x2 y2 and C x3 y3, whose sides are again ABC given. Then the coordinates of the end center, point of intersection of angle bisector. What is in center? Point of intersection of angle bisector is given by ax1 bx2 cx3 upon a plus b plus c, ay1 by2 plus c by 3 divided by a plus b plus c. Again, this is very rarely used. Okay, not you'll find a lot of PYQs on this, but a straightforward formula is there. It's not any harm to remember this. Okay, so rarely used, but still, please keep this in mind. Centroid, this is a very common. Very common. Okay, how do we get centroid, bacha? Simple. In the same triangle, if I talk about, I already drew the triangle over here. In the same triangle, if we try to construct the medians, what is medians? Midpoint of this line, let's say I call this to be point P for this one. Okay, let's say Q and R. Then we get the midpoints. What is the meaning of midpoint? Means this side and this sides are equal. Same goes for everything. Okay, so this is going to be called as AP, and this is the BQ, and we have CR. So AP, BQ and CR is what? Are the medians. And the point of intersection is not coming like this actually. It's not accurate. So I'll try to erase this and write it again to make this as per this question. Okay. So basically this is your point R. Yeah. So this point you see over here is called as point G, which represents centroid. Okay, centroid is the point of intersection of all three medians of a given triangle. Point of intersection of medians. And how do we get the coordinate? Simply taking the sum of the vertices that you have. x1, x2, x3 by 3, y1 by 2 by 3 by 3. I hope you can find it over here as well. x1, x2, x3 by 3, y1, y2, y3 by 3. Okay, alright. Acha, one more thing. If it is in 3D space, we can use again same thing. x1, x2, x3 by 3, y1, y2 plus y3 by 3, and the last one z1 plus z2 plus z3 by 3. I have one important result to tell you all about this. Is what you did to find centroid. In centroid, you use the over here. What is this? We used coordinates of vertices, right? We use the coordinates of vertices to get the result, this formula. If we use, and if we have been given, okay, if we use what, sir? If we used what? The coordinates again of midpoints also. Midpoints also. For example, can we find midpoint coordinates, sir? We can do that. x2 plus x3 by 2. y2 plus y3 by 2. Okay. So if you use the coordinates of midpoints also, you'll get the same result. We will get same result. Do not worry, when I talk about the chapter 3D geometry, I'll include this concept furthermore, okay? But right now understand this, if over here we are using x2, x3, x1, x2, x3 as the coordinates of vertices, but even if we, instead of having these given, if we had 3 midpoints given and we use the coordinates of the 3 given midpoints, we'll get the same result for centroid, okay? So this is clear. Moving on. Now we move on to the line part. Slope of a line. How do you find slope of a line, sir? So if this is your x and y axis and the line is something like this, okay, and let's identify 2 points on the line, point A, and over here we have, let's say, point B, okay. So each point will have coordinate, right? So this means this will be your some coordinate, correct? This will be your, sir, y2, and over here we'll have x2. Same over here we'll have, sir, y1, and here we'll have x1, okay? This is called as theta. How do you find this distance? This is given by y2 minus y1. Am I right? y2 minus y1. And what about this distance, sir? This is given by x2 minus x1. You all agree, right? If this distance is x2 from here to origin, then this will be what? x1. So difference becomes x2 minus x1. So slope of a line has a formula. What is that? Tan theta. Has a formula? Tan theta. Apply tan theta in this triangle that you have. Can you see the right angle triangle over here? You get what? You get this value of tan theta is equals to what? Please check. Opposite. So y2 minus y1 upon x2 minus x1. This is basically the formula of slope. Tan theta or y2 minus y1 upon x2 minus x1, okay? So if I draw the triangle again that we got over here and used over there, this value is y2 minus y1, sir. This value is x2 minus x1. This was your point B. This was the point A, by the way, okay? And this is your, let's say I call this point to be C. So it's right angle at C. Yes, this is not A over here. Yeah. The y1 is not here. One second. This is the point A. This is C, and this is your y1. I hope it makes sense. So this is how we find and understand the concept of slope of a line. So slope of a line when coordinates of any 2 points of the line are given. Okay, same thing. So this is what we have. When we have coordinates of 2 points are given, so this is what we use, y2 minus y1 upon x2 minus x1. Now some of students or teachers might tell you to write this value also. It is correct. y1 minus y2, x1 minus x2. Just remember, if you're writing y2 first, write x2 first. If you're writing y1 first, write x1 first. So your choice, okay? But you can write any one of them. I hope this is clear. Okay, moving on. Slope of the line Lx plus My plus n. If you're looking to find the slope of this line, always remember we know something called as slope intercept form equals to y as mx plus c. Okay, so try to convert this into this form. What you're gonna get is basically you'll get the slope as, if you convert this, you'll get Lx on this side, sir. If I have to show you, Lx plus My plus c equal to 0, right? So right here, My equal to minus Lx minus c. So you get y value as minus L by m x plus c by m. Excuse me. Yeah. Minus c by m. Compare here. We are getting here minus L by m as my slope value. Please check. Same thing over here. So either you can use the slope intercept form of equation, or simply, please check, or simply use this formula, coefficient of x upon coefficient of y with a minus sign. If you have this standard form given, start with minus of coefficient of x upon coefficient of y. Slope of a line equally inclined with x-axis, both the axes actually, is either 1 or minus 1. Is 1 or minus 1. How come, sir, 1 or minus 1? If you go like this is the inclination. What is the slope over here, sir? This is minus 1, because this value will be 135 degrees, and here the slope will be minus 1. But if you talk about the other curve, what is the other curve? This is the other curve. When you go and have the slope like this, equally inclined, this value will be what? 45 degrees. This will be 45 degrees. Over here, slope becomes 1. So the slope, if you have a line equally inclined to both the axes, then the slope can be either minus 1 or plus 1. Okay. 3 points ABC are collinear if and only if AB, slope of AB and BC are equal. Think about it. A here, B here, C here. This is the meaning of collinear points. ABC is the same line, so of course slope of AB is equal to what? Slope of AC. They are the same line, no? Or BC, whatever you want to say. Okay, equal to slope of BC. So equal, sir. Okay, moving on. This is clear, guys? Yeah. Now, angle between two lines. Angle between two lines. This is basically over here like this. This represents your line with the slope m1, with the slope m2. Then this acute angle, theta, is given by tan theta equals to, actually there is a modulus sign over here. It goes like this. Tan theta is equals to modulus m1 minus m2 upon 1 plus m1 m2. Same thing is over here with the, if you remove the modulus, you will have what? You will have plus minus sign. m1 is what? Tan theta of 1. Some angle will be there, no? Tan theta 1 represents angle of this line m1 with the positive x-axis. This is your theta 1. And this represents what, bacha? This represents that if you draw a line over here, this angle will be your theta 2. Angle of the second line with the x-axis, theta 2. Okay, same thing. Taking tan inverse on that side. If it is acute, it will turn out to be positive. Okay, got it? Yes. If lines are parallel, then tan theta will be 0. You get what? You get the value of m1 equal to m2. Let me conclude over here. For parallel lines, this is very important. The question will come from here. Condition is m1 equal to m2. Okay, and for perpendicular lines, what happens in this case? Basically, m1 into m2 equals to minus 1. Okay, remember both the formulas. Very, very important. All right, guys. Thus, so this is the condition. Parallel lines are always equal slope, and for perpendicular lines, the product is equal to always minus 1. Okay, always minus 1. Okay. If the lines are perpendicular and slope of one of the line is m, then of course other will be what? Minus 1 by m. How come we can say that? m1 into m2 is minus 1, right? So m2 is given by minus 1 by m1. Same thing is written over here. Nothing different. Very simple concepts. Okay. Slope of a straight line equally inclined to two given lines. Okay. Basically, let's say these two lines are equal, right? And this is a line which is equally inclined to both these lines. This angle is equal. In that case, if I have this curve slope, this line slope is m, this is going to be, let's say, m1 and m2. Okay, because any line will have its own slope, right? Then basically this is the result that we have. Slope is given by m minus m1 upon 1 plus m1, where m represents the slope of the given line. Same if you want to write in terms of m2, this is what we have. The relation is this. Please check. Okay, the two lines has the slope m1, m2, and the straight line that we're looking to find has a slope m. Okay, which is equally inclined to both the lines. Got it? Please check. Next, equation of line in standard form. So what is this we have, sir? We have this one only. We just saw right now. Ax plus by plus c equal to 0, where a represents what? Of course, coefficient of x. B is, sir, coefficient of y, and c is the constant term. The constant term. We know very well that the powers of x, y, z has to be, xy has to be what? 1, 1, because it is a linear equation. Linear equation represents the straight line. So of course the power of x and y will be only 1. Don't have this confusion that it can be anything other than 1. Okay, it will be always 1 only. Okay. Now if you talk about the different forms that we have, basically we can identify those and convert those into these forms also. So let's look at these individually. 2-point form, what it means is when you have 2 points given, x1 y1 is given and b x2 y2 is given, then how do we write the equation of this line? Using this, the formula is y minus y1 equals to, you do this, y2 minus y1 upon x2 minus x1, and we have x minus x1, where this particular value represents what, sir? Slope. This represents slope. I hope it makes sense. The equation I wrote right now is the equation when you have 2 points known, how to identify, how to write the equation of a line. So 2-point form. Slope intercept form, this is very simple one. Y equal to mx plus c. M represents slope and c is the y-intercept. If you want to write in terms of x, you'll get what? X equals to my plus c. Okay, in that case, you'll have a different effect. Intercept form, this is very interesting one. This is what? X by a, y by b equals to 1, where a is what, sir? X-intercept, and b is what, sir? 1 second, Vicha. B is y-intercept. B is y-intercept. Okay, this is the intercept form. Now point slope form, when you have slope and point both given, so basically y minus y1 equals to m times of x minus x1. So if you check carefully this form and this form, so you can directly relate. Correct, no? This m is given. Okay, actually this and this are directly related because this represents what? M only, no? So y minus y1 m times of x minus x1. This is more of the same thing. Okay, simply this is after simplification. So these are the 4 major forms of straight line which we use very commonly in our questions. Okay, please check. All right, guys. Okay, now in the knowledge hub, equation of any line parallel to a given line will have the same coefficient. Please check. Will have the same coefficient. This is ax plus by. This will also be, sir, ax plus by. Just the constant c will change to k because it is a parallel line, not the same line. Okay, yeah. Equation of a line which is perpendicular will have the coefficient reversed with a sign change. We have ax plus by. Over here we'll have bx minus ay. So coefficient reversed with sign change. Okay, got it? Here you can see minus bx plus ay. Coefficient reversed with sign change. This is the case for perpendicular. This is the case for parallel. In parallel, coefficient remains same, only the constant changes. Yeah, I'm going faster. It doesn't have to be because it is actually a simple session. That's why it looks faster. Okay, yeah. All right, so what do we have? Distance of a point from a line. Distance of a point from a line. Okay, so very simple. So straight line given over here. Is a line means you'll have an equation. Let's say the equation is ax plus by plus c. And there's a point means you'll have a coordinate known, x1, y1. Then this is called as the distance. Let's say in this case p. And the formula for this one is over here. Basically, so in this case, this is taken as capital A, but I hope you get the point. Let me just write in that format only in that case. Yeah. This is, sir, basically ax and by. Then the answer is given by a times of x1, b times of y1 plus c divided by square of a and b taken in the root. Okay. This is the formula for length of perpendicular from the point this to the line given over here. Okay, if you talk the same thing with the origin, beta, please check. This is origin. What will happen in the case of origin? This x1 comma y1 I wrote will become what? 0 comma 0. Yes or no? From origin, if I am talking about, this will become 0 comma 0. So this will be what? 0 into a, 0 into b. That's 0. So only c is left. That's why it is c by a square plus b square. Make sense? Same. This is basically the main formula from where we get the result that we have over here. Got it? Yeah. This is the same thing. This and this is the same thing because distance of a point from a line or perpendicular is the same thing. Because when you talk about distance of a point from a line, you talk about what? Perpendicular distance only. Okay. Moving on. The distance between two parallel lines. In that case, what will happen? You're gonna introduce because they're parallel means they have the same slope, right? They have the same coefficient for y and y. So you're going to take the difference of C1 and C2 divided by 1 plus m square. Okay, if they're parallel. In general, from two lines, if you're looking for, you'll have this as C1 minus C2 divided by root of a square plus b square. The two different lines are given, ax plus by plus C1, ax plus by plus C2. Okay, if they're given in the general form. If they're given in the intercept form, you're going to use this one directly. Please check, slope intercept form is given, no, mx plus C1, mx plus C2. Use this one result. But if you have, what do you call, if you have this result where ax plus by plus C1 is given, over here also ax plus by plus C2 is given, this is the result we're going to use, okay? I hope this makes sense. Come on. This is clear, right? Yeah. Next, mirror image of a point with respect to a given line, okay? So this is the first case where you talk about reflection, means this is the line which is given to us. The line is ax1, my bad. The line is ax plus by plus c equal to 0, and you have a point over here x1 y1. If you take the image of this point, the image will come like this, and this, let's say the coordinate of the image is what, x2 y2. This represents, let's say this is your point A, then this will become what, sir, a dash, and this is the point of, basically reflection, so O. Okay, so the point a dash coordinate is given by this. How do you find a dash coordinate, sir? So you have to find the value unknown, which is x2. So simply take this result. Please check, everything is known over here. 2 is a constant. Small a is known from the coefficient of, from here. x1, y1 is also known, c. So everything over here, you can see that in this bracket, everything is known values. They're all known parameters or known values. Now, so only unknown that if you're finding x2, you will multiply a over there and add x1. Multiply, you're going to take this and this together to find x2. Okay, you'll get the value of x2 from here, whatever it is, and from here you're going to get the value of y2, whatever it is. And what is x2, y2? The image of the point x1, y1 in the line ax plus by plus c. Now, if you go to find in this second case, this is the second case, excuse me, just about to complete this particular chapter. Okay, if this is the point, same thing, x1, y1, this is the same line, ax plus by plus c, then this point O, this is a, no, this will become your x2, y2, and this is called as foot of the perpendicular, coordinates of foot of the perpendicular. So here x2, the unknown value, is meaning what? x2, y2 represents the foot of the perpendicular, coordinates of foot of the perpendicular drawn from the point x1, y1 to the line ax plus by plus c equal to 0. Okay, please check again. To find x2, you're going to use these two to find x2 value. Okay, and to find y2 value from here, you can use to find the y2 value. So this is again a known value. This is the known quantity. Please check. All right. Two problem solving now. Let's solve some questions on the practice, on the application of the concept that we learned right now. So what do we have over here? The slope of the straight line which does not intersect x-axis. Think about it. Does not intersect x-axis means it will be parallel to x-axis, right? Any line L1 which is not intersecting the x-axis, it means parallel to x-axis. So what's the theta value over there? Theta value is, sir, 0. What are we looking for? Slope. M is what? Tan theta. So tan of 0. Answer is what? 0. So your question has the answer now as option D. If a line is parallel to or not intersecting the x-axis, slope is 0. Perpendicular or intersecting at right angle, infinity. Okay. If a line through the point this and this is perpendicular to the line through the point, so let's do one thing. Let's find the slope from here. Okay, we'll get what? Let's say 8 minus 6, then we'll do 4 minus of minus 2. 8 minus 6 is 2, 4 minus of minus 2 is 6. We get the value as 1 by 3. Okay, 8 minus 6 is 2, 4 plus 2 is 6. M2. Let's find M2 now. 24 minus 12 and x minus 8. We get here 12 upon x minus 8. They are saying this is what? Perpendicular in nature. It means what, beta? M1 into M2 is what? Minus 1. What I get for this? 1 upon 3 into 12 upon x minus 8 is minus 1. 3 4s are 12, right? So I get this value as 4 equals to minus x plus 8. Cross multiply. Move on this side. X into minus 1 is minus x plus 8. Bring this x over here and 4 over there. We get x value as 8 minus 4. X value is simply 4. So answer is clearly option D. Answer is clearly option D. Okay. Now, next question. If P is the length of perpendicular from the origin to the line, okay, how do you find the to this line? Okay, think about it. So if you compare over here, the coefficient is what? 1 by A. From here, the coefficient it was 1 by B. What is the formula? If you remember, the distance is given by, they're saying that distance is P. Okay, perpendicular distance is given as P. We have A x1 B y1 plus C upon root of A square plus B square. X1 y1 is, sir, origin, right? Means 0 comma 0. Check here, I'll have only C left. So C upon this value, A square plus B square. This is in the modulus. So what is the C value over here? This is equal to 1. Okay, this is equal to actually 1. So move on this side, it will become minus 1. So your C value is minus 1. So your P becomes, please check, mod of minus 1 upon root of 1 plus 1 upon A square, 1 upon B square. Check. Take whole square over here, it becomes P square, 1 upon A square, 1 upon B square. Move this on this side and this over here. You get 1 upon A square plus 1 upon B square equals to 1 upon P square. Right? Right? Let me check. That's your answer. Option is A. They're asking us 1 upon P square, no? So answer is this over here. Please cross check. This is your final answer. I hope this is clear. Yeah? All right. Okay, so this is going to be the end of your chapter straight lines. All right, so I have catered to all the concepts, even something additional, because the chapter is easy, so let's not miss any marks over here. So everything is covered. I have solved some questions also. So please, if you have to watch this session again, PU1 chapters are easier in nature. You got to put more effort over here. So do make sure that you are watching and solving all these questions and going through all the concepts again. Okay, let's have a look. Yeah, let us look at the one-shot lecture, the one-shot session for the chapter Conic section, right? So over here, if you check, so this chapter, as we all know, is majorly about the formulas. So I'll show you the formulas, but over here you got to start remembering the formulas. We'll not put too much time into this because it's more of efforts to be put on your side, and of course if you have done that, you'll get the question right every single time. So formulas is what is the key over here in this chapter Conic section. Let's start. Okay, so sections of a cone. So if you see a double napped cone means if you basically take an axis and take a line like this, okay, a line like this, and start making this line go over here. So basically like this, if I have, okay, I have another pen, I'll show you, 1 second. Yeah. So if you take an axis like this, please check, and over here, try to move it like this. What are you getting? Please check. You're getting a formation of a double napped cone. Means it is a cone with having two sides in it. It's a cone with having two sides in it. Please check. So two cones in it. It's a cone which is having two shapes. So double napped cone. Okay, up and down. This is called as axis. This inclined line is called as generator. Angle of generator with the axis is called as alpha. This is upper nap and lower nap. Clear? If you revolve this like that across it, okay, you'll get the double napped cone. In this only we create the sections. I'll show you. So when you create sections like this, when you create a plane, this is what beta represents. Beta is what? Angle of plane with axis. Okay, so if this angle is 90 degrees, if the angle is 90 degrees at a right angle, okay, the plane is what? At right angle to the axis of the cone. This gives you a circle. Please check, observe it very clearly. You're getting a circle over here. But if you incline, if it is something less than 90, okay, and more than 0, in that case this becomes what? this particular value becomes actually a little inclined, and this gives you something called as ellipse. It's called as ellipse if you look at more cases of the conic sections. So if you check over here, in the case where this beta, what is this beta, sir? Angle between the plane and the axis becomes equal to the alpha, then this plane becomes parallel to the generator. This is what is this line called as? Generator line. Generator and this becomes parallel, and then you get the case of parabola. Okay, and for hyperbola, when this is what when this is going to be cutting plane of this is further inclined over there, okay, then what happens? It becomes it cuts double napped cone. It cuts two places, so you get two axes. So can you check this? You're getting something like this. This gives you hyperbola. This gives you hyperbola. So this is how you create sections using double napped cone. Now some conditions that you have: when beta is 90 degree, the conic section that you get is circle. When beta is between alpha and 90, you get conic section which is ellipse. When beta is equal to alpha, you get conic section which is parabola. And when beta is between 0 and alpha, you get conic section which is hyperbola. Okay, so I hope this is very, very clear. Now comes your basic definition part and the formula part. A circle is the locus of a point. What is this? When it moves, that basically locus of that point, sir, which is always at an equal distance to the fixed point. What is it? The locus of a point which is always at a fixed distance to a fixed point. Okay, okay. So this distance is constant, and this distance is called as radius, and the fixed point is called as center. Okay, the fixed point is called as center. The constant distance is called as radius, and the fixed point is called as center. Okay. Standard equation of a circle, if you go, x minus h the whole square, y minus k the whole square equal to r square. What is h and k? H and k represents beta. H and k represents your center. H and k is the center. Yeah, check here. H and k is the center. Note, h, if you're writing x as h plus r cos theta, y equal to k plus r sin theta, this is the parametric form of what? The coordinates of the center of a circle. Okay, parametric equations or coordinates of the circle. Okay, moving on. Come on. Now, when we talk about points inside, on the and outside the circle, whenever this point P or the distance CP is what? Less than the value AR. Basically, CP is, C is the center, P is the point, whichever point we're talking about. So when CP is less than R, this point P lies inside the circle. Okay, because CP is some length which is less than the radius. Okay, same value. CP is equal to radius. It means the point lies on the circle, and CP is more than the radius. It becomes point lies outside the circle. Okay. Okay. Sorry. Lies. This is wrong. Okay. Outside the circle. Outside the circle. My bad. Typing mistake. This is outside the circle. On circumference, you'll have when CP and R are equal. Okay. Next, parabola. What is parabola, sir? Very simple. So in the previous case of a circle, what did we say? We said that locus of a point which is always at a fixed distance to the given fixed point. Okay. In this case, what happens? We talk about that distance of a locus of all the point which is always at a fixed distance to a point and to a fixed line. Okay. Means, so if I take this to be point A and this to be, let's say, point F, okay, then distance AF will always be equal to, this distance. Okay, let's call this to be, let's say, C. So AF and AC will always be equal. What is this called as? Locus of all those points, okay, of any point which is always at a fixed distance to a point and to a fixed line. The fixed point is called as foci and the fixed line is called as directrix. Okay, please check. The fixed point is called as focus of the parabola and the fixed line is called as directrix of the parabola. You'll find the definition everywhere in the NCERT, not a problem. I'm just trying to give you the explanation of this. Straight line perpendicular to the focus to the directrix is called as axis. This becomes your axis, sir. This is the directrix, sir. Okay, and this is the focus, sir. The point of intersection of parabola with axis, this is called as, sir, vertex. This is called as vertex. Okay. Yeah, and chord passing through the focus, this one, basically this one is called as, this is the focus, right? This is called as latus rectum. It's called as latus rectum. Please check. Yeah. All the definitions will have some formulas also involved, so let's look at that. Okay, ratio of the distance of any point from the focus of the distance to the point of from directrix is called as eccentricity. This value is, so over here, SP by PM, SP by PM. So basically, in this case over here, if you draw the parabola, no, again let's say, okay, so SP by PM in this case, please check, this is the P, this is M, this S, this will be, yeah, ratio of distance of any point from the focus, so this will be basically S over here. One second, I forgot to write the coordinates. Yeah, this will be basically S over here and M over here, SP by PM. Got it? Yeah. Parametric coordinates of parabola is given as 80 square and 280. Rarely used, but still good to know it. Okay. Yeah. Next, list of formulas for all these forms. Whether it is a form of the different parabola. What is this parabola, sir? Y square equal to 4ax. This is the parabola, symmetric about x-axis and on the right hand side. This is what? Symmetric about x-axis on the left hand side. It's not the image. This is the parabola. In this case, symmetric on the upward side. This parabola is again symmetric about the y-axis and downward sides. There are 4 different forms of parabola that we have. Again, equation of axis you can see, y equal to 0, this is the x-axis. This is same x-axis only. This is the x-axis, no? This is your axis over here. This is going to be the axis y and y. Okay? That's why it is x equal to 0 and y x equal to 0 in the last 2 cases. Please check. Equation of directrix, you can see the form over here, minus a, minus a and a. Okay? Vertex is what? Always at origin only, because you have y square and y square. Okay? Next, focus is given as you move over here, we have a comma 0, we have minus a comma 0, we have 0 comma a, and we have there minus a 0 comma minus a. Okay? Length of lattice rectum will remain always same as 4a only. Yeah. Now ellipse. In ellipse you have the figure and it goes like this. This line is called as major axis. If you reverse the ellipse, conjugate ellipse if you take like this, then this will become your major axis in that case. Okay, so basically everything is going to be reversed over there. Right now it is minor axis, so in this case it will become minor axis. Okay, we have 2 foci over here, S and S dash. These are called as foci or focuses, and basically plural of focus is foci. So this is our S dash and this is S. Okay, so S and S dash is your foci, and basically again, so the distance over here, this point is called as AE comma, this is foci means AE comma 0, AE comma 0, this is plus A, this is minus AE. This distance from C to A, this value is called as A, sir. This is going to be again another A value, and so on. Okay, so let's go. An ellipse is the set of all points in a plane, the sum of whose distance from the given 2 fixed points. Means if I take a point over here P, then PS dash and PS is always fixed. PS dash and PS, sum of this is always a fixed value, and this value is actually always 2a. Okay, we'll learn it later, but this is always 2a. Got it? And these fixed points are called as foci. The 2 fixed points are foci, and the midpoint of the line joining the foci is called as center of the ellipse. This point is center of the ellipse. In this case, origin. Okay, the line segment passing through the foci with endpoints A and A dash is called the major axis of the ellipse. Please check. This one I'm talking about, major axis. Yeah. Next, the line segment perpendicular to that is called as minor axis, just the opposite way in the y-across axis. The extremities of the major axis are called as vertices. What is this, sir? Over here, this point you see, vertex A dash and vertex A. Everything is noted over there. Yeah. The ratio of distance of any one focus from the center and the distance of any one vertex from the center is called as eccentricity. And what is the formula for this value? This is the formula. 1 minus b square upon a square in the root is called as eccentricity E. Okay. Radius rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci and whose end points of the lie on the ellipse. Okay. So this is the value LR. Please check. LL dash, that is your latest rectum, this value. Passing through the foci touches the ellipse. This is your latest rectum. Yeah. Don't worry about the formula. We have all of this over here. Length of the latest rectum is 2b square by a. And forms of the ellipse, this is when A is on the major axis, A is more than B, you can see that. So this is the major axis form. The conjugate will be just opposite, okay? Equation of major axis will be what? Y equal to 0, x-axis, and everything. Length of major axis is 2a. Equation of the minor axis is x equal to 0. This is the y-axis, okay? Length of minor axis will be 2b. Equation of directrix is what? Plus minus a by e, because we have 2 over here. 1 on this side, this is minus a by e, this is plus a by e. This is what? Excuse me. Let me just write that over here for you. This is, sir, directrix. So a by e, and this value is, sir, minus a by e. Got it? So try to remember this from the figure perspective, okay? It'll be easier for you to remember. There are many formulas. Vertex of ellipse, again I explained to you already. The two end points on the major axis. Focus on the ellipse, AE, 0. Yeah, I just explained over here as well. This point S actually has a coordinate AE, 0, and this S dash has a coordinate. This S dash has a coordinate of minus AE, 0. Okay, got it? Yeah, that's not visible, so let's just erase that. Why to have the confusion? Yeah, 1 second, guys. Moving on. What else? That's all. Yeah, length of rectum is given as, this is the LL dash value. This is the LL dash value. Let me tell you. Yeah, this value LL dash. It'll have the same value over here also. 2b square by a. 2b square by a. I've written the value of eccentricity over here. You can check. Yes. So I hope this is clear. And this is again in the parametric form. Okay. X is a cos theta and y is b sin theta. Theta between 0 and 2 pi. Okay. Parametric form. Clear. Yeah. Next is what? Beta, hyperbola. Okay. How does this look like? Over here. Again, here also formulas are very, very important. This is the case of hyperbola with x as the transverse axis and y as the conjugate. You can reverse also. You can go like this as well. Okay. This is also okay. Hyperbola, this is the first case that you can see, and the conjugate is over here. When the basically here a value is more than b, if you reverse it, it will be what? Basically b value is more than a over there. So center will remain same. You have all the equations. Please remember it, very, very important. Here we have a, 0. Here we have the foci on the y-axis. You can see that this is the foci. So basically over here also I can tell you this is the foci. Okay. This is the vertex, sir. This will represent, sir, vertex. This is a focus, sir. Over here also these two are foci. Okay. Length of major axis, focus coordinate also given 0 plus minus a. So a plus minus a, 0. For the y-axis we have 0, plus minus b. Okay. More formulas over here. Equation of directrix, plus minus a if the focus is if the main parabola means even a is more than b. For conjugate we have plus minus b by e. Okay. Vertices are again known. What is vertices, sir? This is the vertices. So a, 0 minus a, 0. Yeah. Eccentricity also listed over here. In this case we have eccentricity is basically given like this. E value is 1 plus b square by a square. The same thing over here. Okay. Length of the rectum is what? 2b square by a. This remains same. Whichever is greater, it goes in the denominator. That's how it is. Okay. Yeah. Parameter in the coordinates a sec theta, b tan theta. Parametric form. Focal radii ex minus a. This is less used. This is less used. This also is less used. This is again used. Okay. Difference of focal radii is s dash p minus sp. Okay. How does it come? In the same format. If you draw this same thing, figure in the format s dash p and s dash p, sp basically, you'll get the result like this. Okay. Great. This is also rarely used. These last four are less used. So less used in PYQs. If you see in the last few questions, last 10 years questions, you have less questions on these forms. Okay. But yeah. Let's look at the questions now. If focus 6, 0, okay, it's a parabola. Okay, focus is over here, 6, 0. Directrix is over here, minus 6. X equals to minus 6. They're asking for equation. This is a simple one. Y square equals to 4 into a is 6x. Answer is 24x. Option A is correct. Option A is correct, guys. Please check. Yeah, I hope this is clear. Next one. The end of a major axis is given. Ellipse. Okay. Yeah, this is 3 and this is minus 3. This is the major axis, means this is x-axis, major axis. So this is 3 and this is minus 3. This is, sir, minus 2 and 2. What are they asking us? Equation of the ellipse. We can do that. X square by square of 3, which is 9, plus y square by square of 2, which is 4, equal to 1. Yeah. Again, option A. X square by 9 upon x square upon by 9 plus y square by 4 equal to 1 is the equation of this given ellipse. I hope it is clear. This one, a very unique question. Most of the student, if this question comes in examination, you will think something about this number. So they have given that root 2009. How do you find this root, sir? Okay, equal to 1. I've taken this question on purpose. So understand this very clearly. What it means actually is, I'll take it over here. So basically it becomes x square minus y square equals to 3 upon 2009. What it basically means that x square upon 3 upon root of 2009 minus y square upon 3 upon root of 2009. This is the ellipse form. So this is the hyperbola form. And what is this? What is this? This is basically a case where a square is equal to b square. A square is equal to b square. This is a square, this is the same thing as b square. It means, and these cases are called as the case of rectangular hyperbola. Hyperbola. Whenever you have rectangular hyperbola, the value of ellipse is always, eccentricity is always root 2. Value of eccentricity is always root 2. Regardless of what is the value of this, does not matter, always option A. How can I say that? Think about it now. This is what we have, 1 plus b square by a square, let's say. This cancels, sir. 1, so E equals to 1 plus 1. Answer is 2. This is the case for what? Rectangular hyperbola. Rectangular hyperbola. Clear now? Please check. So this completes your chapter conic section. I know I have kept it very to the point, not wasting your time, because I could have gone more in depth, but not required. Okay, you just have to go through the formulas approach, solve some questions on it, solve some PYQs on it, and KCET pattern problems. Whatever exams you're writing, those exam pattern problems, Comet K, KCET pattern problems. So that will actually help you understand and get the most of from this chapter. Okay, so very, very straightforward questions are there. I hope this is clear. Yeah, moving on. So this is the end of your chapter conic section.